Dimensional analysis. In this section, we will learn dimensions, dimensional formulae, dimensional equations and its applications. Meaning of word dimension in physics. We will encounter two meanings of word dimensions in physics. One definition of dimension is the type of category of a measured quantity, and other is like one-dimensional, two-dimensional or three-dimensional space. We won't encounter the other definition until next chapter. For example, distance may be measured in feet, meters or miles, but all these measurements are units of length. So, the dimension of distance is length. The symbol we use to express the dimensions are only the fundamental physical quantities. So, we use 7 symbols for 7 fundamental quantities, which are denoted by capital letters. Remaining all derived physical quantities are expressed in terms of dimensions of fundamental quantities. The dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. Dimensional quantities are represented in square brackets like this. For example, we represent length by capital L in square bracket, mass by symbol capital M in square bracket, time by symbol capital T in square bracket, electric current by symbol capital A in square bracket, temperature by symbol theta or K in square bracket, luminous intensity by CD in square bracket, and amount of substance by mole in square bracket. If x represents a distance which has dimension of length L, we write this as x in square bracket is equal to capital L in square bracket. Similarly, a velocity v has dimensions of length capital L per time capital T. Thus, we write capital V in square bracket is equal to capital L in square bracket upon capital T in square bracket to indicate its dimensions. We can also write it as V is equal to L into T to power minus 1. Acceleration A, which is the change in velocity per time, has the dimensions A is equal to dimensions of V upon dimensions of T. As dimensions of V are Lt to power minus 1, therefore A is equal to Lt to power minus 1 upon T is equal to Lt to power minus 2 in square bracket. Now volume occupied by an object, V is equal to length into breadth into height. Therefore, dimensions of V is equal to dimensions of length, which is capital L, dimensions of breadth, which is also capital L in square bracket, and dimensions of height, which is also L in square bracket. Therefore, dimensions of V is equal to LQ. Now, some important points about dimensions. First point is pure numbers and pure ratio do not have any dimension. That is, these are dimensionless. For example, refractive index, relative density, cos theta, pi, strain, etc. Now, second point is logarithmic functions as log x, e to power x are also dimensionless quantities. Third point is powers are dimensionless. For example, in this expression, the power of L is 3 and number 3 is dimensionless quantity. Now, dimensional formula. The dimensional formula is defined as the expression of the physical quantity in terms of its basic unit with proper dimensions. For example, dimensional formula of velocity is Lt to power minus 1. We can also write it as m to power 0 L into T to power minus 1. These powers are dimensions. That is, dimension of velocity in mass is 0, as the power of capital M is 0 here. Dimension of velocity in length is 1. 1 is the power of L. Dimension of velocity in time is minus 1. Here minus 1 is the power of T. We can also obtain unit of physical quantity by using the method of dimensions. To write unit, just replace dimensional symbol by their units. For example, dimensional formula of velocity is V is equal to Lt to power minus 1 or m to power 0, L to power 1, T to power minus 1. To write its SI unit, replace m by kg, L by meter and T by second. That is, unit of velocity is kg to power 0, meter to power 1 and second to power minus 1. That is, unit of velocity in terms of fundamental units is meter second to power minus 1 or meter per second. As acceleration a is equal to change in velocity upon time, therefore dimensional formula of acceleration a is equal to dimensional formula of velocity upon dimensional formula of time. As dimensional formula of velocity is Lt to power minus 1 and dimensional formula of time is capital T, therefore dimensional formula of acceleration a is equal to Lt to power minus 2 or a is equal to m to power 0, L to power 1, t to power minus 2. Therefore dimension of acceleration in mass is equal to 0. 0 is the power of m. Dimension of acceleration in length is equal to 1. 1 is the power of capital L in this expression. Dimension of acceleration in time is equal to minus 2. Minus 2 is the power of capital T in this expression. To get the SI unit of acceleration, we replace m by kg, L by meter and t by second in this expression. We get SI unit of acceleration is equal to kg to the power 0, meter to the power 1 and second to the power minus 2. That is meter second to power minus 2 or meter per second square. Similarly, force is defined as F is equal to ma. That is F is equal to mass into acceleration. Therefore, dimensional formula of force is equal to dimensional formula of mass into dimensional formula of acceleration. That is m into Lt to power minus 2 is equal to m Lt to power minus 2. Therefore, dimension of force in mass is equal to 1. It is power of capital M in this expression. Dimension of force in length is equal to 1, power of L in this expression. And dimension of force in time is equal to minus 2. It is the power of capital T in this expression. Now, SI unit of force in terms of fundamental units is equal to, just replace capital M by kg, L by meter and T by second. In this expression, we get SI unit of force is equal to kg to power 1, M to power 1, second to power minus 2. That is kg meter second to power minus 2. As mass density rho is equal to mass upon volume, therefore dimensional formula of mass density is mass upon volume is equal to capital M upon L to power 3. L cube is the dimensional formula of volume is equal to m L to power minus 3. That is dimensional formula of mass density is m L to power minus 3. Therefore, dimension of mass density in mass is equal to 1. It is power of m in this expression. And dimension of mass density in length is equal to minus 3, power of L in this expression. And dimension of mass density in time is equal to 0. It is the power of T in this expression. SI unit of mass density in terms of fundamental unit is equal to kg to power 1 meter to power minus 3 is equal to kg meter to power minus 3. Now, dimensional equation. An equation is obtained by equating a physical quantity with its dimensional formula is called the dimensional equation of the physical quantity. For example, dimensional formula of volume is m to power 0 into L to power 3 into T to power 0. If we write it as capital V in square bracket is equal to m to power 0, L to power 3, T to power 0, it is a dimensional equation for volume. Similarly, for velocity or speed, if we write V in square bracket is equal to m to power 0, L into T to power minus 1, here V represents velocity or speed. It is the dimensional equation for velocity or speed. For force, dimensional equation will be F in square bracket is equal to m Lt to power minus 2. And for mass density, rho in square bracket is equal to m L to power minus 3 T to power 0. If you know the formula of any physical quantity, you can always write its dimensional formula or dimensional equation. Now, applications of dimensional analysis. First application is conversion of units from one system to other. This is based on the fact that the product of the numerical value and its corresponding unit is constant. That is, numerical value into unit is equal to constant or nu is equal to constant. Suppose it is your equation 1. So, when the unit will change, numerical value will also change. If n1, u1 are the numerical value and unit respectively of a physical quantity in first system, and N2, U2 are the numerical value and unit respectively of the physical quantity in second system, then according to equation 1 we can write N1 U1 is equal to N2 U2. If U is equal to M to power A, L to power B, T to power C, then U1 will be equal to M1 to power A, L1 to power B, T1 to power C, and U2 will be equal to M2 to power A, L2 to power B, T2 to power C. From this equation, we can write N2 is equal to N1 into U1 upon U2. Put the values of U1 and U2 in this expression. N2 is equal to N1 into M1 upon M2 to power A into L1 upon L2 to power B into T1 upon T2 to power C. To illustrate this concept, I am giving you an example. Example is value of gravitational constant G in SI system is given by G is equal to 6.67 into 10 to power minus 11 Newton meter square upon kg square. Find its value in CGS system. The dimensional formula of G is m to power minus 1 L cube into T to power minus 2. If N1 represents magnitude in SI unit and N2 in CGS unit, then N1 U1 is equal to N2 U2. This implies N1 value of U1 is M1 to power minus 1 L1 to power 3 into T1 to power minus 2. Just write M1, L1 and T1 for MLT in this expression is equal to N2 M2 to power minus 1 into L2 to power 3 into T2 to power minus 2. Just write M2 for M, L2 for L and T2 for T in this expression. This implies N2 is equal to N1 M1 upon M2 to power minus 1 L1 upon L2 to power 3 T1 upon T2 to power minus 2. Here the value of N1 is numeric value in first system. It is 6.67 into 10 to power minus 11. M1, L1, T1 are the fundamental units in SI system. M1 is 1 kg, M2 is 1 gram, L1 is 1 meter and L2 is 1 centimeter, T1 is 1 second and T2 is also 1 second. So cancel this 1 second with this 1 second. You will get N2 is equal to 6.67 into 10 to power minus 11 as 1 kg is 10 to power 3 gram. So write 10 to power 3 gram here upon 1 gram power minus 1 into as 1 meter is 10 to power 2 centimeter. Therefore write 10 to power 2 centimeter here upon 1 centimeter whole power 3. Cancel this centimeter with this centimeter, gram with gram. You get N2 is equal to 6.67 into 10 to power minus 11 into 10 to power minus 3 into 10 to power 6. It will be equal to 6.67 into 10 to power minus 11 into 10 to power 3. 6 minus 3 is 3. It will be equal to 6.67 into 10 to power minus 8. Therefore, in CGS units, the value of G is equal to 6.67 into 10 to power minus 8 dyne centimeter square upon gram square. Now, second application is to check the dimensional correctness of a physical quantity. This is based on the principle of homogeneity. According to this principle, the dimensions of each term on both sides of an equation must be same. If the dimensions of each term on both sides of an equation are same, then it is called dimensionally correct equation. But it may or may not be physically correct. If an equation is physically correct, then it will also be dimensionally correct. For example, time period of a simple pendulum is given by t is equal to 2 pi square root of L upon G. Dimension of left hand side is equal to dimension of time t. It is capital T in square bracket. Dimension of right hand side is equal to dimension of 2 pi square root L upon G. 2 pi is dimensionless constant is equal to dimension of length upon dimension of acceleration G. It is LT to power minus 2. Cancel L with this L. It will be equal to T to power plus 2 whole power 1 upon 2. It is equal to capital T in square bracket. Since dimensional formula of LHS is equal to dimensional formula of RHS, therefore the given expression T is equal to 2 pi square root of L upon G is dimensionally correct. Now example second. Suppose we want to check the correctness of equation v is equal to u plus at. Here dimension of v is equal to lt to power minus 1. Here v and u are velocities, a is acceleration, t is time. So dimensional formula of v is equal to lt to power minus 1 and dimensional formula of u is also lt to power minus 1 and dimensional formula of at is equal to dimensional formula of acceleration a into dimensional formula of time t. The dimensional formula of acceleration a is lt to power minus 2 and dimensional formula of time t is equal to capital T. It will be equal to lt to power minus 1. Here it is clear that dimensional formula of v is equal to dimensional formula of u is equal to dimensional formula of at. As for an equation to be dimensionally correct, the dimensional formula of each term should be same. Therefore, the given equation is dimensionally correct. But v is equal to 2u plus 3at is also dimensionally correct because dimensional formula of v is lt to power minus 1. Dimensional formula of 2u is equal to dimensional formula of 2 into dimensional formula of u. Since 2 is a dimensionless quantity and dimensional formula of u is lt to power minus 1, therefore dimensional formula of 2u is equal to lt to power minus 1. Similarly, dimensional formula of 3at is equal to dimensional formula of 3 into dimensional formula of a into dimensional formula of t. 3 is dimensionless quantity. Dimensional formula of a is lt to power minus 2 and dimensional formula of time t is capital T in square bracket. So, dimensional formula of 3at is equal to lt to power minus 1. Since dimensional formula of v is equal to dimensional formula of 2u is equal to dimensional formula of 3at, therefore, the given equation v is equal to 2u plus 3at is dimensionally correct, but it is not physically correct. The correct equation is v is equal to u plus at. Thus, we can say that a dimensionally correct equation may also be physically incorrect equation. Application 3 is to stabilize the relation among various physical quantities. If we know the various factors on which a physical quantity depends, then we can find a relation among different factors. It is used as a research tool to derive new relations. For example, Stokes' law has been developed using this principle. It is found experimentally that viscous force depends on radius r of the sphere, velocity of the sphere and viscosity eta of the liquid. So we write F proportional to eta to power x, r to power y, v to power z. It can also be written as F is equal to k, eta to power x, r to power y, v to power z. Here k is a dimensionless constant, x, y, z are unknowns to be determined. To be a correct equation, it should be dimensionally correct. So write dimensions of both sides of above equation. We get dimension of force is equal to dimension of k into dimension of eta to power x, dimension of radius r to power y into dimension of velocity v to power z. K is dimensionless quantity. Dimensional formula of F is mlt to power minus 2 is equal to dimensional formula of k. It is a dimensionless quantity. So leave it. Dimensional formula of eta is ml to power minus 1 t to power minus 1 to the power x. Dimensional formula of r is L, its power y. Dimensional formula of velocity v is lt to power minus 1, its whole power z. It will be equal to m to power x, L to power minus x plus y plus z into t to power minus x minus z. Equating the dimensions, that is powers of similar quantities, we get x is equal to 1. The power of m is x in right side and power of m is 1 in left side. So x is equal to 1. Suppose it is your equation 1. Power of L in right side is minus x plus y plus z. So minus x plus y plus z is equal to power of L in left side, it is 1. So it will be equal to 1. Suppose it is equation second. Power of t in RHS is minus x minus z and power of t in LHS is minus 2. So minus x minus z is equal to minus 2. On adding first and third, x get cancelled and we get minus z is equal to minus 2 plus 1. That is minus z is equal to minus 1 or z is equal to 1. Put these values of x and z in equation second, we get minus 1 plus y plus 1 is equal to 1. This implies y is equal to 1. Therefore, f is equal to k eta to power x r to power y v to power z is equal to k eta to power 1 r to power 1 and v to power 1. That is, f is equal to k eta rv. As experimental value of k is 6 pi, therefore f will be equal to 6 pi eta rv. Now fourth application is to find dimensions of physical constants or coefficients. Suppose there is a physical equation with a constant. We can find out the dimensions of that constant by substituting the dimensions of all other quantities. For example, Newton's law of universal gravitation is given by F is equal to G m1 m2 upon r square. Here G is a universal gravitational constant. From this expression we can write G is equal to F into r square upon m1 into m2. Therefore, dimensional formula of G is equal to dimensional formula of F into dimensional formula of r square upon dimensional formula of m1 into dimensional formula of m2. As dimensional formula of F is m Lt to the power minus 2 and dimensional formula of r is L, therefore m Lt to the power minus 2 into L square upon m square. It will be equal to m to the power minus 1 L to the power 3 into t to the power minus 2. Now limitations of dimensional analysis. The method of dimensions has the following limitations. First limitation. By this method, the value of dimensionless constant cannot be calculated. Second point, by this method, the equation containing trigonometric, exponential and logarithmic terms cannot be analyzed. Third is, if a physical quantity in mechanics depends on more than 3 factors, then relation among them cannot be stabilized because we can have only 3 equations by equalizing the powers of m, l and t. Fourth point is, it does not tell whether the quantity is vector or scalar. The question is, the period t of a simple pendulum is the time for one complete swing. How does t depends on the mass m of the bob, the length l of the string and the acceleration due to gravity g. Now pause the video and try to solve the question yourself. Solution is, let t is proportional to m to power x, l to power y into g to power z, or t is equal to k m to power x, l to power y, g to power z. Suppose it is your equation 1. Here k is dimensionless constant and x, y and z are to be determined. Write the dimensions of each quantity. We get dimensional formula of t is t, k is dimensionless quantity, dimensional formula of m is capital M, its power x, dimensional formula of length is capital L, its power y, dimensional formula of g is Lt to the power minus 2, its power z, that is t is equal to m to power x, L to the power y plus z, t to the power minus 2z. We can also write it as m to power 0, L to the power 0 into t is equal to m to power x, L to the power y plus z into t to the power minus 2z. Now comparing the dimensions of both sides, we get power of m in RHS is x and power of m in LHS is 0. So x is equal to 0. Let it is your equation 1. Power of L in RHS is y plus z and power of L in LHS is 0. So y plus z is equal to 0. Power of t in RHS is minus 2z and power of t in LHS is 1. So minus 2z is equal to 1, that is z is equal to minus 1 upon 2. Let it is your equation third. Now using third in second, we get y minus 1 upon 2 is equal to 0, that is y is equal to 1 upon 2. Using these values in equation 1, we get t is equal to k m to power 0, l to power 1 upon 2, z to power minus 1 upon 2. That is t is equal to k square root of l upon g. This is your required expression for time period of a simple pendulum. This analysis will not yield the value of k, but we have found that the period does not depend on the mass. A derivation in terms of forces acting on the bob shows that k is equal to 2 pi. Therefore, t is equal to 2 pi into square root of L upon g. Your assignments in PDF format are given in description link. Please download and try to solve these assignments. If you have any problem in assignments, then just write question number in comment section. I will provide you the solution. For regular online physics classes, please subscribe my channel. Thanks for watching.